Hello, in this video I will talk about the AES cryptology algorithm that I did during my internship at Tech. First of all, I would like to tell you in this short video how the keys required for AES are generated at each step. We take the last column of the 128-bit key, perform the operations specified in the video, and generate the necessary keys for each round. Here I have defined a lookup table for the sub-byte operation and used the Archon matrix to take a different matrix for each step. In this part of the video, I try to indicate what steps the AES password goes through in general. After AES XOR the key that needs to be encrypted with the key entered, it enters the loop that will perform the steps of a subbyte, shift rows, mix columns, and add round key, and the loop is repeated according to the security level of the password. It can process 9, 11, or 13 times. Loop then performs the last step and generates the password so as not to do the mix column operation. I used the MATLAB program to verify the VHDL results of AES. First, I wrote a MATLAB file operations code to create AES cipher and key files. I obtained 3 files from the MATLAB application and saved these files to the verif file for future use in MATLAB and VHDL language. In order to do AES operations, I created 6 MATLAB file codes and prepared the MATLAB code to save the files with the txt files. This M file reads the information from the file, that is, takes the cipher and keys and passes the values received through the AES cryptology algorithm and saves the results in the text file. The file input txt file is as in the figure, and the result obtained after processing with AES is as in the text file. Here, I wanted to show the VHDL file I created for the AES algorithm via Notepad++. The VHDL code consists of a 10, 12, or 14-step finite state machine, and the required round results are obtained at each step. I have done the necessary instantiations here, and I have created a code bundle of 100 lines beforehand for each. I specified the VHDL files I wrote for AES and other operations. Here, I created a library for each file and kept it ready to use for future encryption. I used QuestaSim for the simulation environment and created the sim file required for it. The part highlighted in red is the sign that the file reading process is complete. Write wallet signal is the signal used for suppressing the result. The results are made in the LR round and written to the file at the next clock. Test out file suppressed txt file for VHDL operations. VHDL takes the necessary cipher and key information from the iCipher and iK txt files and writes them into the test out file. Here I have compared test out and all MATLAB outputs file, so I compared my VHDL and MATLAB code results and tested their accuracy for both systems. This was the trailer for my AES cryptology algorithm. Thank you for listening to me. Please do not forget to comment.